Everyone can see, yes?
Yes, it looks great.
Okay. Hey everybody, so we are McMaster AutoPlow and we are working with the region of Peel to build an autonomous snow plowing robot. So here's our team. We'll start with Yushang. He is part of software. He's also the glue. Rehan is part of business and outreach. Nolan is our mechanical lead. Lisha, me, I'm also part of business and outreach. Deep is our safety and quality guy, and Charlotte is also helping with software. The challenge that we're dealing with Peel is that snow removal, specifically on sidewalks, is very costly in terms of time and money, and they rely on passive forms of snow removal, such as salt. So we want to try to do this in a more environmentally friendly way. And our key insights with talking to Peel have been route management. If they're going to clear these sidewalks in an automated way, it needs to prioritize the highly trafficked ones first so that they can meet their service level agreements for snow removal. We also need to not rely at all on ice as a form of snow removal. It's a huge pollutant, or salt rather, it's a huge pollutant. And we also need to consider that the physical components, the wheels, other parts of the robot need to be able to accommodate outdoor terrain and sidewalks. And Ray is going to describe our problem to you.
All right, so what problems are we facing? Snow buildup and salt dispersion throughout Peel region impacts pedestrians and residents. Snow melting salt leaves a damaging environmental footprint both to wildlife, the drain and sewage systems. It requires a lot of expensive manpower, and it also requires third-party outsourcing from Peel a region. But we offer a solution. What reduces manpower significantly is the self-driving capability, and we've centered our design around that. Equipped with sensors such as a GPS and a LiDAR, the robot would traverse sidewalks effectively, applying snow. Paired with a quick deployment time, energy-efficient battery-powered drivetrain, it would be incredibly environmentally friendly. And finally, would work directly with Peel, mitigating any use of a third-party client, saving a lot of time.
Sorry, I was on mute there. As of right now, the primary mechanical projects are focused on prototyping, so such as like designing and 3D printing a camera clip and a caster wheel mount, which you can see on the slideshow there. We're also planning other engagement opportunities with these kind of mechanical needs, as well as conceptual sketches and plans for some future designs that have a bit more complex systems involved.
Thanks, Nolan. Over the past 9 months, we've been working on sensor testings, indoor mapping localizations, and outdoor GPS-based simulations. Regarding AI, we've been preparing our customized object detection neural network, which includes people using wheelchairs as part of our dataset. This will help us improve the inclusivity and reduce biases of our algorithm. I'm going to hand over to Deep.
Thank you, Yuzhang. In terms of what makes our solution really unique, it's our three major bottom lines: our social, our environmental, and our economic. So from an economic perspective, our self-driving technologies that we'll be producing will have the potential to reduce cost of hiring contractors and other human capital. In terms of our social factors, we're looking at our solution that will make city sidewalks more accessible and help build a community that is not just technical, but also raising awareness of using technology for good. And finally, in terms of our environmental factors, we're looking at reducing snow meltage usage, and by doing that, we're protecting our Ontario rivers, lakes, and overall ecosystem from algae bloom caused by oversalting.
Right. The main bulk of the investment is poured into software licensing. These programs are run to test and improve the robot. Since it's also made in house, we need to buy 3D printing filaments to build most of the parts. Once we've built the mechanical and electrical parts, we would need a chassis to house everything together effectively. I know it sounds expensive, but in the long term, it's going to be extremely reliable and functional.
And to summarize, we are continuing to work on our robot for Peel, low cost development, self-driving and environmentally friendly. And our next steps are continuing to work with students and faculty at MAC, as well as our employer partners, to make sure our software and hardware is performing to the level that we hope it will. And that's all. And Yusheng is showing you the robot.
Great job, team. A virtual round of applause and right on time, so that's great. Up next, we have the City of Toronto's team led by Tina. And then on deck, we have Environment Hamilton led by Usman and Paige.